Okay, this is lesson 7.3, arcs, inscribed angles, and central angles. In comparison to the last lesson, 7.2, which was super easy, this one is a little more, well, maybe even more than a little more. It's significantly more challenging, a little more time consuming. So the lesson is also going to be a lot longer. I'm going to try to give you breaks where I can talk a little bit and then you can work on some of the assignment as we go along, but this is going to take some time, so I hope you're comfortable. So just take a minute here and jot down the objectives. We first need to talk about what an arc is. There are two kinds of arcs. There's a major and a minor arc. Then we have to talk about what an inscribed angle is and how that relates to an arc measure. And then we have to talk about a central angle and how that relates to arc measure. So the first objective here, this first one, arc, both major and minor, that's not going to take very long. It's these other two, inscribed angles and central angles, that may take a little while. So hopefully that was enough time. If not, I guess you can pause it here real quick, but I'm going to move on here. So draw a circle and label a couple of these points on the outer edge of the circle. Now an arc is a portion around the outer edge of a circle. So if you start tracing around the outer edge of the circle, you're tracing what's called an arc. All the way around the circle is what's known as a circumference. That's just an arc. A circumference is an arc. So the two types of arcs, if we start at point A and measure directly around the circle to point B, the notation for that arc is the two letters AB with this little semicircle thing, I guess, above it. This is the notation for arc. Now, this in particular, arc AB is a minor arc. Because we notice we haven't gone very far. We've certainly gone less than half of a circle. And so that's what a minor arc is. It's because it's less than half of the circle. Now, as you might guess, going around more than half a circle is a major arc. Now you have to be careful about how you describe this. Let me do a different color here. If I start at point A and want to go the other way around to point B, then notice how I pass through point C as well. It's important that you make note of that when you're talking about the name of this arc. You have to name the points that you pass through. So the name of this arc is actually arc ACB. It started at point A, went through C, and ended up at point B. So the name of the arc is ACB. And arc ACB is a major arc because it's more than half of the circle. So you have minor arcs, you have major arcs. You also have some special ones like I just talked about a few minutes ago. All the way around a circle is called a circumference. If you go exactly halfway around a circle, that's a semi-perimeter or a semicircle. So if you've had a chance to jot all that down, that was objective one. That was really all there was to it. It was defining an arc, both major and minor. So that'll come up a little bit later on the assignment. The next topic here are what are called inscribed angles. So draw another circle. And label some points around the outer edge of the circle, and then draw an angle starting from point A to B to C. The important thing to note here is that the vertex of the angle lies directly on the outer edge of the circle. That's the characteristic of what's called an inscribed angle. So here angle ABC is an inscribed angle because the vertex is on the edge of the circle. That's important. The vertex has to lie directly on the edge of the circle. Just because an angle is inside doesn't mean it's an inscribed. For example, this angle right here, if I did this angle DEF, this is not an inscribed angle because the vertex is not on the outer edge of the circle. So now if we started at point A and ended at point C, that's called the intercepted arc. The reason it's the intercepted arc is notice the sides of this angle. We have that angle A, or that side there, and this side here. So those sides, if we were to extend those sides through the circle, then the arc would start at one side of the angle and it would end at the other side of the angle. That's called the intercepted arc. Now, we've talked a lot about the measure of angles, but what about the measure of an arc? Arcs are measured in degrees as well as angles are measured in degrees. But if it's an inscribed angle, the relationship between the measure of the angle and the measure of the arc is that the angle is half. So, for example, let's say that we knew that the angle was 80 degrees. The inscribed angle was 80 degrees. What that means is the arc from A to C is 160 degrees. That's the relationship. The measure of the inscribed angle is half of the measure of the arc. And the vice versa is true. If we knew, for example, let's say we knew that the arc was, I don't know, 150 degrees. That automatically means that the inscribed angle is half of that. So that would be 75 degrees. That's the relationship between an inscribed angle and the measure of the arc. Arcs are measured. The measure of an arc, the unit of measure there is degrees. So hopefully you have your homework out. I want you to take a look at questions 1 through 4. I've got it right here somewhere. Questions 1 through 4. First of all, you have to look at the angle here, DCE, and decide if it's an inscribed angle. So for question 1 it is, because the vertex right here is on the outer edge. So if it is, name the angle and the intercepted arc. Now, I want you to be specific here and name the angle using all 3 of its letters, D, C, E. So the way that you would answer, there's 3 things you got to answer here. First of all, yes, because it's an inscribed angle. Second, name the angle. It's angle DCE. And then you have to name the intercepted arc. So let me actually get something so I can draw on this here. So for question 1, what you ought to be doing is saying yes, because it's an inscribed angle. Name the angle. It's angle DCE. And then name the intercepted arc. So if you extended the sides of the angle, then the arc is from here to D to E, so it's arc DE. So I'm going to ask you to pause it here, and it shouldn't take you more than a few minutes to answer questions 2, 3, and 4. If it's an inscribed angle, the answer is yes, and then name the angle and the arc. If it's not an inscribed angle, you don't have to worry about it. So, getting back to this, question 2, the answer was yes, it's an inscribed angle. The angle is JLK. Now you got to be real careful here on how you have answered question 2, in particular the name of the arc. So the arc is from here to here, but because it starts at J and passes through point Q, you have to list point Q as part of that arc. So the arc is JQK. The angle is angle JLK. This one wasn't even an inscribed angle because this vertex is the center. That's actually a central angle, which we're going to talk about here in a few minutes. And then same thing on 4. The answer is yes. The name of the angle is angle E, G, and then the name of the arc, if you start at F, you have to pass through D before you eventually get to G, so it's arc F, D, G, like that. It's pretty sloppy. Let me try that again. F, D, G. There we go. So, moving on, these now get quite a bit more complicated. Not that the arithmetic involved is hard. It's actually pretty easy arithmetic. All you're doing is adding and subtracting to either 180 or 360. But you've got to be, oh, clever is not the right word to use for some of you. I don't know, you really just have to think, and these answers might not just come to you immediately like most of you would like. You have to think and be patient and really just sometimes wait for this to come to you. We are going to have to make use of what we just barely talked about, inscribed angles and arc measures. So take a minute here and draw that circle. I want you to draw everything how I've drawn it. If you need to pause it here for a second. You guys should be paying attention to this and not working on the homework right now. So the question is to find the measure of the indicated arc. You notice a question mark here that's indicating that we need to find the measure of that arc from D to P. Now, a couple of things. If we knew the measure, let's take a look at the intercepted arc and the angle. A couple of things we could try. If we knew the measure of this angle right here, then we would just double that. That would be the measure of that arc. Unfortunately, it's not going to be very easy for us to find the measure of that angle, so I wouldn't recommend going that route. Notice we do have the measure of an angle right here, though, 35 degrees. If we trace that angle right here, that will tell us this arc from there to there. That's the intercepted arc that matches this inscribed angle. If the angle is 35 degrees, then that arc is 70. Now here's where you have to be clever. Notice this line right here from F to D. That's a diameter because it goes right through the center of the circle. What a diameter does is it cuts a circle directly in half. We have a top hemisphere here and a bottom hemisphere. I don't know if I mentioned this, I think I might have forgotten, but all the way around a circle, a circumference has a measure of 360 degrees. That's if you go all the way around a circle. So what if you go halfway around a circle? If I started at D, went through point P, and ended up at F, let me do this in a different color here. If I went through starting at point D to P and all the way to F, this semicircle or half of a circle, that's going to have a measure of 180 degrees. Why is that significant? Some of you might have gotten it by now. We already know that from here to here is 70 degrees. If we know that the entire measure of this half circle is 180, and then what we're trying to find is the measure of this arc right here. I know this is getting pretty messy, but we're trying to find the measure of this arc from D to P. Well, if you take 180 and minus 70, that leaves an arc measure of 110 degrees. Now, before you move on to your homework, I want you to consider this one here. So if you need to real quick, pause this so you can have a minute to draw that. You need to be as detailed as you can. But just so I don't sit here while you're drawing this by myself, I'm going to ask you to pause it so you can draw. So now that you have it, the directions here are exactly the same. Find the indicated, or find the measure of the indicated arc. So if you notice the question mark, that means we need to find this arc right here. So here we go. This is kind of an involved problem. Notice we do have a couple of angle measures here. First of all, I'm going to focus on this angle measure, 119 degrees. If we follow the angle and extend it, then the intercepted arc between the sides of that angle is from F all the way through G all the way to H. Now we notice there's 168 degrees. That's only from G to H. So from G to H is 168 degrees. That's what that means. Now, if you remember what we talked about a few minutes ago, an inscribed angle is half of the measure of its intercepted arc. So since the angle is 119, if you double that, the measure of the arc from F all the way around to H is going to be double 119. What's double of 119? It's 238. So from F, measuring around the circle all the way to H, that should have a measure of, if I can write, 238. Now, that's the measure of the whole arc from here all the way to there. We know that a portion of it, starting at G to H, is 168. So what does that mean? What does that mean about the measure of the arc from F to G? Well, if we take 238 and minus 168, 238 minus 168, that's 70. So we know that this portion has to be, do that in a different color, that portion from G to F has to be 70. Because 70 plus this 168 right here is going to give you the entire arc of 238. Now, why were we so focused on finding the measure of that arc right there? Now we have to consider the other angle in this shape that's been given, 65 degrees. If we follow that angle here and here, if we now trace the intercepted arc of that angle, we're going to start at G, go through F, and end up at V. I know it's getting kind of messy, so please try your hardest to focus in on what's happening here. If the angle is 65 degrees, the inscribed angle is 65 degrees, that means the entire intercepted arc from one side of the angle to the other side of the angle is double that. Okay, if you take 65 and double it, you get 130. So the measure of the entire arc from here to here, from one side of the angle to the other side of the angle, should be 130. Well, we know a portion of that, right, from here to here. If you see where my pen is pointing, from here to here, we already knew that was 70. What portion now is missing? And this is what we're trying to find, is this portion right here. What portion is missing that we can add to 70 to make 130? And that's going to be 60 degrees. So from F to V, the measure from F to V is 60 degrees. So now get your homework back out. I want you to take a look. I'm going to help you with 5 and 6, and I want you to try 7 and 8. So we'll do 5 and 6 here, and I'm going to have you pause it, and you can work on 7 and 8. So, now you're supposed to find the angle here where the question mark is. In order to do that, we're going to have to know the measure of this arc right here from the sides of that angle. Once we know the measure of this arc, we cut it in half, and that's going to be the measure of the angle. So, and this is something that's very, very often overlooked, but it's so important that you get used to spotting this. This right here from M to K. Notice this line. I should do that in a different color. Let me see. Let's do that in blue. Notice from M to K, that's a diameter. From M to K, because it goes right through the center of the circle, that's a diameter. What that means is it cuts the circle directly in half. This portion of it is exactly half of a circle, so that we know from M all the way to K, since that's half a circle, we know that that's going to have a measure of 180 degrees. So if you're looking carefully, we know that this portion right here, from K to, can't even see what that is, and I think whatever that is right there, we know that this portion is 70. So what does this portion have to be in order to make the half a circle of 180 degrees? And it has to be 110, because 110 plus 70 is equal to that 180, or half a circle. Now that we know that this arc right here, the intercepted arc is 110, we cut that in half to find the inscribed angle, which is 55 degrees. Now, number 6, notice this line here from L to M does not pass directly through the center, so this is not a diameter, so we can't claim that this is 180 degrees. It'd be nice, but we just can't do that. Notice though, if we considered angle M right here, okay, the arc between the sides of that angle is 104. Notice that this is also an inscribed angle, so the inscribed angle is half of its intercepted arc. If the arc is 104 degrees, that means the angle is 52 degrees. Now I know we weren't supposed to find this angle here, we're supposed to find this angle, but notice the triangle now, you have two of the angles that you need. Add it together, subtract from 180. That should give you that missing angle. That's a very similar way that you're going to solve problem 8. The problem 7 here is a lot like the one on the notes that we just did. So I'm going to ask you to pause it here. I want you to work on 7 and 8. Do it in groups. Collaborate. That's a really important skill you guys need to start doing. And then we'll move on. So the answers for 6, 7, and 8 for number 6 it was 77 degrees, for number 7 it was 98 degrees, and for number 8 it was 45 degrees. I'll go over these next time if you're having questions, but that's what the answer should have been. Now, getting back to our notes here. Example 3. Take a minute here and sketch that circle. This one, in comparison to the others we've been doing, is much easier. Not nearly as involved. So what we have here is another inscribed angle, because the vertex is on the outer edge of the circle. If we consider the angle now, and then also consider the intercepted arc between the sides of that angle, we know the arc is 192. That means the measure of the angle is going to be half of that. If we take 192 and divide it in half, 192 divided by 2, that's 96. So the measure of the actual angle itself is 96 degrees. And that's really what we're going for. The angle is 31x plus 3. But we also know the angle is equal to 96 degrees. So 31x plus 3 is equal to 96. All I got to do now is solve for x, subtract 3. You get 31x is equal to 93. Divide by 31. And you get x is equal to 3. I'm going to give you a minute here in just a second to do a couple more homework problems, so just hold off. Let's do example 4 here. So take a minute. Again, if you need to pause it, go ahead and pause it so you can copy this down. Now we need to find, you have to read these directions extremely carefully. Now we're not simply solving for x. We actually are supposed to find the measure of angle NLM. So put a question mark here. This is angle L, or rather NLM. That's the measure of the angle. So to answer this question, if we consider extending that angle and then finding the arc that's between the sides of that angle, we need to figure out the measure of the arc from N to M. Once we know the measure of the arc, we cut it in half, and that would be the measure of the angle. Now, again, I've said this before, I'm going to say it a couple more times, but this is often overlooked. But if you consider the line from L to N, that line goes right through the center of the circle. That makes this a diameter, which also makes the right part of the circle exactly half of a circle. Half of a circle is equal to 180 degrees. So if we take the measure of this arc here in red, which is 13x minus 10, and if we add the measure of the arc that's in black, so we have 13x minus 10 plus this arc here, 7x minus 10, because those two arcs form a semicircle or half of a circle, we know it has to equal 180. So solving this, if you take 13x and 7x, that's 20x. Negative 10 and negative 10 makes negative 20. That equals 180. Add 20 to both sides. You have 20x equals 200. You divide by 20, you get x equals 10. Keep in mind though, the directions weren't simply to solve for x. It was to find the measure of angle NLM. Now that we know what x equals, we can plug it in right here for this x. 7 times 10 is 70 minus 10 is 60. So the measure of the arc is 60 degrees. Because this is an inscribed angle, we know that that angle is going to be half. So the angle is 30 degrees. So again, if there's time and you're going to have to decide, there's still a little bit more to go with central angles. So if there's time for you to start working on problems, where are we, 9, 10, 11, 12, you can take a minute, pause it here, and work on a few of these. There is about 10-15 more minutes left of notes, so just keep that in mind. So the next part of notes here, central angles. If we consider this angle A, B, C, notice now where the vertex of the angle is. The vertex of the angle is right in the center of the circle. It's a central angle is what this is called. Now, this is actually a pretty nice relationship between a central angle and the arc. If we consider the arc between the two sides of that angle from A to C, so the measure of a central angle is equal to the intercepted arc. So let's say, for example, we knew the measure of the arc from A to C was 100 degrees. That automatically means that the central angle is 100 degrees. That's the relationship here. They're exactly the same. Whatever the central angle is, that's the measure of the intercepted arc. So before I actually get too much into measures of angles, matter of fact, just to save time since this is so easy, rather than doing example 5 here, just let's go to your homework here, and specifically problem number 19, 20, 21, and 22. just because these are pretty easy. So if an angle is given, name the arc that it makes. If an arc is given, name the central angle. So from number 19, if you take a look, angle 3 is the one we need to focus at. So that's the one that's been given. So if you look down here to angle 3, it's a central angle. So all you need to do is name the arc, the intercepted arc, which is arc CD. Or on number 20, they want you to look at arc BC. So if you look at arc BC, what's the central angle forming that arc? And obviously it's angle 2. So don't want to skip over that necessarily, but it's a pretty easy section. So that's what that is talking about. Just for sake of time, let's maybe move on here to this example. So we're going to call this example 6. So again, if you need to pause it to draw this down or to draw this, go ahead and pause it real quick, but you need to make sure that you have this written or this picture drawn. The directions here are to find, this little M stands for measure, so we're supposed to find the measure of arc CFD. So if you start at angles or point C, and this, the direction here is clear, we have to go from C to F and then to D. So if we go from C, if we go from C, there we go. So from C to F all the way to D, we need to find the measure of this arc. Now, couple of things that we don't want to overlook, and this is always something, always that you should pay attention to. This right here is a diameter. Okay, that means that the entire arc or measure is 180 degrees. So if we know this portion right here is 135, we know that that is 45. Now these are all central angles because the vertices of all these angles are at the center of the circle. So if the angle is 135, that means that this arc from here to here is 135. That means that this arc from here to here is 45. That means that this arc from here to here is 81. Now here's something interesting. These two angles right here, because they're formed from two intersecting lines like this, they're vertical angles, so that's 45 degrees, which means that's an arc of 45 degrees. So keep in mind what it was we were trying to find. Starting from C, going all the way around through F to D, we're supposed to find the measure of that arc. Well, all we've got to do is add up the individual measures of those smaller arcs. So on a calculator, it's going to be 45 plus 135 plus another 45 plus 81. So the measure of arc CFD was 306 degrees. So that's like on your worksheet, numbers 23, numbers 24, number 25, number 26, actually pretty much the whole entire end of the worksheet. So one more quick example here. If we want to find the measure from M, and this is actually an angle now because that's an angle symbol. We want to find the measure of M to I to J. So we want to find the measure of this angle right here. What we're going to have to figure out then is the measure of the arc from J to M. If we knew the measure of the arc, then that's going to be the same as the measure of the angle. Now, right here, if this is 55-degree arc, that means this is a 55-degree angle. Because there's two intersecting lines here, they form vertical angles, so that's also 55 degrees. Notice also that this line right here that I'm highlighting, that's a diameter. So this whole entire, let me do that in a different color. This whole entire arc on this portion of the circle, since that's half of a circle, that's 180 degrees all the way around. From here to here, that's 180 degrees. We know that this is 55 degrees. So then what's the portion from K to L? Well, if you take 180 minus 55, that's 125. So this arc from here to here, that's 125. That means that's a 125-degree angle there. Because these are vertical angles, that's 125 degrees. So actually, I guess we didn't need to figure out the measure of that arc. We just need to figure out the measure of the angle on the other side, because they were vertical angles. So the measure of angle MIJ is 125 degrees. So that's pretty much it to finish up the assignment. Whatever time you have left in class, you can use it working on the assignment.